So there are going to be two kinds of material. Yeah, materials can be either conductors or insulators. Yeah, conductors are the ones where electricity can be conducted. Yeah, that means we are talking about electrical conductor, not thermal conductor. That's a different phenomena. So in terms of electricity, whether they can conduct charges, that means the charges are free to move or not. Based on that, you can classify material as conductors and insulators. So here, free to move. Conductors means free to move. In insulators, charges are not free. There are no free charges for it to move inside the material. So in conductors, charge can flow freely. So what does that mean? For example, if you have two objects that are, let's say one object is positively charged, that means its electrons have been removed out. Its electrons have been removed out. The negative charges have been removed, so it becomes positive. So this positive body, if it is brought close to a neutral object, that means it has same number of plus and minus. If I have 3 plus, it has 3 minus. It's neutrally charged. If I bring in a metal rod and place it between these two objects, what's going to happen? What's going to happen is, so this guy might have maybe this many pluses and this many minuses, right? So equally number of plus and minus. Once I bring this in, the negative charges from here are going to flow into this. The negative charges from here are going to flow into this. Why is that so? Because this guy is positively charged, and positive charge attracts negative charges, isn't it? So it's going to attract all the negative charges from here to here, until the point that the number of positive charges here and here are the same. Till the point that the number of positive charges here and here are the same. That means the number of electrons that transfers over will be almost 3. If you were to look at this picture, this 3 is going to be the number of electrons that moves in here, so that this eventually becomes 3 positive charges here and 3 positive charges here, so that both of them are having equal amount of positive charge. But does that happen if I were to not bring in a metal, but instead if I were to bring in wood? The metal is going to have so much of negative charges that are going to be available for it to go. Whereas in wood, right, those charges are not free to move. This wood will not allow any charge to flow through. Whereas in the metal, it's very easy for it to make it flow through. So that means wood is a insulator and metal is a conductor. So how can an object be charged? How can metals be charged? For example, metals can be charged, conductors can be charged in two ways. One is called conduction, the other one is called induction. So what do we mean by that? Conduction means there has to be a contact. Induction means contactless. So conduction means there has to be a contact, physically touching, then the electrons will flow. For example, here, if it's a neutral rod, metal rod in the first place, if you bring in a charged object and bring in contact with each other, that means these two are going to touch each other, then what's going to happen is this guy has lost a lot of negative charge already. So this guy has lots of negative charges free to move, yeah? So he has multiple plus charges and he has multiple negative charges. He's neutral, right? Number of positive and negatives are there. Once you bring into contact, right, this guy is so short of negative charges that he's going to pull all the negative charges from here, because negative charges get attracted to him, yeah, because he's positively charged. So if this rod now starts to lose the negative charge, he becomes positively charged. So if he has lots of negative charge, he's going to be able to provide all that. If not, he's going to become positively charged because he's lost few electrons to this rod that is coming in contact with it. Coming in contact, yeah, so the keyword is conduction. How about induction? You don't have to really come in contact, yeah. So what you see here is the induction process, where when you bring this guy close to the charged rod, close to this metal rod, what used to be very close, the plus and minus all to be very close to each other, they get polarized, yeah. They're getting the so-called polarized. So polarization happens. That means the plus becomes one side, the minus becomes one side. So here the same concept here, but then this guy is not free to move because the air in between is not a conductor. The air that is around us is not a conductor, and that's good for us. Yeah, if air were to be conductor, you would be electrocuted every other time. Yeah, so air around is not a conductor. Yeah, lightning is one phenomenon where air becomes ionized and starts to conduct electricity. So what happens now? How to make this rod then positively charged? Then you go ahead and ground it. Yeah. So once you ground it, there are free electrons, as many as you want in this direction to flow from the ground, or as many electrons to flow out to the ground. Imagine ground to be a very big metal that has lots of enough electrons to be either to supply you or to sink, to either to supply as a source or to sink. So once this ground is able to ground all the electrons, sink all the electrons, then when you cut off the ground, this rod now becomes naturally positively charged. This rod becomes positively charged. So those are the two phenomena where you're having conduction and induction, two mechanisms in which a metal can be charged. But how about if you take a non-metal, non-conductor, which is, you call it as an insulator. An insulator is also called as a dielectric. It's also called as a dielectric. Both are the same, insulator or dielectric. It is the same, yeah. Insulator and dielectric, they are the same. So when you do that, what happens? Yeah, in an insulator, unfortunately, the charges are not free to move. They can't move freely. So what happens is all that they can do is, instead of the plus and minus, they can just get polarized, and you create this so-called dipole, what we'll call as the dipole moment. Later on, you will see that all that they can do is, within the confinity of how much the plus and minus can separate, only that much they're going to separate. It's not like the negative is going to break away and free to move. Cannot. Yeah, they are still, the plus and the minus are happily married together. It's just that they are having a little bit of polarization. It's not that one divorces the other and goes off.